So today we're going to talk about inverses. And when we're talking about inverses, basically the main thing we're talking about is a reflection. How many of you know what reflections are? Usually most of the reflections we do are over the y-axis or over the x-axis. Okay, so if you remember in geometry, hopefully you did a lot of reflections over both of them. Okay? Well, when we're talking about inverses, we're talking about a reflection over the line y equals x. Okay, so that diagonal line that runs across your screen, okay, that you can think about. Well, we're going to do a little activity here that shows how your calculator will show you what the inverse is going to look like if you have a function. Okay? It won't give you the actual function itself, but it'll at least show you what it looks like. Okay? So what I want to do is we're going to graph 2 to the x power and its inverse. So go to your y equals and put in 2 to the power of x. And make sure you're set on the standard viewing window. So make sure you're at zoom 6 when you see this graph. Okay. All right. Now I want you to put in y2 then, put in the line just y equals x. All right. So when you have both of them, it looks like this. Now when we do the reflection over the line y equals x, that means that everything that is, in this case, above the line is going to be below the line then. Okay? All right, because it's going to, everybody, you know what a reflection is, right? Okay, it's a 90, or it's a perfect perpendicular. Okay, so if we connected specific points, they would be perpendicular to each other through the line y equals x. Right? So if you do, to get the inverse, you press second program. Okay, program is right here in the middle, right next below the stat key. And then go down to where it says draw inverse, which is number 8 on mine, probably on yours also. Hit enter. All right, and now it asks you to which go to your y equals. Got it? Okay. Now we have to put y1 in here, okay, because that's where our function that we want to show the inverse is at. So to put y1 in here, you have to go to vars, which is variables. Okay. All right, so VARS, and then y variables. So variables, VARS, and then over to y variables, and then function. All right, and then there's all your y equals are there. So you can press enter at y1, and then press enter telling them you're done, and you can see that it draws the inverse in there then. Okay, so now the only thing is that this helps me in one area. It tells me that I can at least see it. Okay, and so I know where it's at to be able to help me if I'm looking for an equation for the inverse and like that. It won't tell me what it is, but at least it'll help me to see it. And this is actually one of the things we're going to be talking about in a lesson or two is this is a logarithm with a base 2. And that's something we'll discuss later. Okay? So we graph them. We graph the function we're looking at. You don't have to graph the line y equals x, but it helps. And then to draw the inverse, we go to second program, and number 8 is draw inverse. And then you put in where your y equals you're looking at. So if it's y1, so you go to vars, over the y vars, and then function. And then into there, and then it'll show you the inverse. Okay. Now, when you go to do a new one then, okay, it'll show you that fine. You won't need to clear or anything like that. Right? So what I want you to do then is that's how you do it. I would like you to do these 4 try this problems here. Okay. All right, so inverses of relations and functions. We think of inverse in a lot of different ways. We've talked about additive inverse, okay, which means that we add the opposite. Multiplicative inverse, which means we multiply by the inverse. And multiplicative inverse of a matrix C, which you may have done. We can also find and apply inverse to relations and functions. To graph the inverse relation, you can reflect each point across the line y equals x. So if you remember in geometry, when you talked about reflections over the line y equals x, that means that we are going to switch the x and y values in ordered pairs. So in every ordered pair I have then, to find the inverse, I'm going to take my x values and my y values, and they're going to switch places. So all the x's will be y's, and all the y's will be x's. So we're going to graph. Here we have this relation here, where it gives us x is 0, 1, 5, and 8, and y is 2, 5, 6, and 9. And we're going to graph it and graph its inverse. And we're going to connect the points. Then we're going to identify the domain and range of each one. So if I graph these points, I've got 0, 2, 1, 5, 5, 6, and 9, 8. All right, and I'm going to connect them. Oops. All right. So if I've connected them, what's my domain? Does it go on forever? No, it doesn't. Between 0 and 8. Okay, so we say that x is greater than or equal to 0, less than or equal to 8. I'm looking at x values when I'm talking about domain. All right, the range. So the y values. Okay, what's the smallest y value? Okay, and what's the largest y value? Okay, I graphed that last one wrong, didn't I? Golly. All right, it's good. A little purple here. And it should be at 8, 9, not 9, 8. There. Okay. So the smallest y value is 2, and the largest y value is 9. So I'll say that y is greater than or equal to 2, less than or equal to 9. All right, domain is x, range is y. So for the inverse then, we switch all of our numbers. So all my y values now become my x values. 2, 5, 6, and 9. And then the y values are now 0, 1, 5, and 8. To find the inverse, you just switch the values of x and y. So when I graph them, I get to point 2, 0, 5, 1, 6, 5, and 9, 8, which I already had up there. And then I'm going to connect them. And tell what the domain and range is. So what's the domain then? Okay, all right. So x is greater than or equal to 2, less than or equal to 9. Okay, and the range is from 0 to 8. So notice what happened. Okay, our domain for our relation is the range for the inverse. The range for the relation is the domain for the inverse. And if we wanted to look at the line y equals x, the line y equals x goes through here just like this. And if you notice, if you look at any of those points, okay, remember we talked about reflections before, right? So that means then that this distance from here to here, if I draw this line here that connects the point and its inverse, they are perpendicular to the line y equals x, first of all. And second of all, what's the distance from the line y equals x to each point? Okay, it's the same because actually the line y equals x is like a perpendicular bisector there. Okay. Okay, so when we're looking at inverses, we're going to switch the values of x and y and graph them. So do this, check it out. Okay, so we're going to look at then, so we did it with relations. So what happens what is it talking about when we're dealing with functions? And what we want to think about with functions is basically when we're talking about inverse, we're talking about undoing things, okay? So think about what happens when you're solving equations, okay? When we're solving equations, we do a lot of undoing of things, right? Because if I had an equation that said 2x plus 3 equals 5, what's the first thing that you would do to solve that equation? What do we do first? We would subtract 3. So we're going to undo the adding of 3, right? Okay. We're going to undo the fact that we added 3 to the x, and we're going to subtract 3. Okay, so we would have 2x equals 2. And then what do we do? Divide by 2, because we're going to undo the multiplication by 2 by dividing by 2. So one of the things how we're going to approach this is we're going to talk about undoing things. Okay? Okay, so this is what's happening to x. So to find the inverse, I'm going to undo those things according to order of operations. Well, when we're talking about the inverse, one of the things we're going to learn to write is the fact that we write an inverse as f inverse of x. Okay, it's not the reciprocal. Okay, it's f to the negative first power of x. That means inverse. So whenever you see f negative 1 of x, that means inverse. It doesn't mean it's raised to a power. That just means inverse. So let's think about undoing things. Okay, what's undoing of adding 6? Okay, subtracting 6. Undoing multiplying by 5. Dividing by 5. Okay, so when we're trying to find inverses, we are actually going to be undoing things. And by undoing things, we're actually switching the values of x and y. All right, so the first one, really easy here. They want us to find the inverse of f of x equals x minus 1/2. Okay, so what's the operation that's happening to x here? We're subtracting by 1/2. And to undo that, we are going to add 1/2. So the inverse of this, I would say f inverse of x is equal to x plus 1/2. And that's it. Okay? That is the answer. Okay? It gets harder than that, but okay? It's as simple as that. If you can think of it as, okay, what do I do to undo the operations that are happening? Okay? Think about how order of operations happen, and think about undoing them. Okay? So we'll talk about the little bit harder ones in a minute. But let's go ahead, and I want you to take a second. I want you to graph both of these. Put them on your y equals and graph them. All right. Okay, so let's answer these two then. Let's go ahead and do them together. F inverse of x, and you're always going to write it as f inverse of x. Okay? Not f to the negative 1, Evan, but f inverse of x. Okay? So this says x divided by 3. Okay, that fraction. So undoing division means we're going to multiply. So f inverse of x would be 3x. Yeah. Very cool beans. It doesn't matter, but the appropriate way to write it is always to put the number before the variable. Okay, all right. Jesse, what's the answer to B here then? X minus 2/3. Okay, we're going to undo adding 2/3 by subtracting 2/3. Now, we're going to get a little bit more complicated, but the thing I want you to understand is just thinking about what would it take to undo the operations. Okay? All right. So here we have the function 3 times the quantity x minus 7. So let's just think about what we would do to x. Hold on. All right. Here's what we would do to the x. First thing we would do to the x is what? Order of operation says we do what's inside the parentheses first, right? So the first thing we would do here is we would subtract 7, right? Okay, if I gave you a number for x, okay, let's say I put 2 in there for x, okay, would you multiply by 3 first or would you subtract 7? Because that's the order of operations, right? Okay, so our first step would be to subtract 7. Okay, now this isn't what we're doing to get the inverse, okay? This is what we would do to x. All right, and then after we subtracted 7, we would do what? Multiply by 3, right? Okay, so multiply by 3. Okay, so then to find the inverse, all right, we're going to work backwards and undo what we just did. Okay, so what am I going to do first then to find the inverse? No, we got to start at the bottom and go up. Okay, we got to undo from there then. So the first thing we're going to do is divide by 3. Okay, there's number 1. And then number 2, we're going to do what? Add 7. So we get F inverse of x equals, so we take x, first thing we're going to do is divide by 3, and then we're going to add 7. Okay? And that's the inverse. Okay? And then we're going to look at it another way too, but I want you to think about it in that form, okay? What would I do? First of all, first thing I'd do here is I would subtract 7 and then multiply by 3. So I work my way backwards, and I'm going to divide by 3 and then add 7. So think of it like this. Okay, you get dressed in the morning, okay, and you put on your underwear, then your pants, and more than likely you might put your socks on before your socks on before your pants. Well, let's think of it this way, okay? Underwear, pants, socks, and then shoes, right? Okay. So if I undo that, okay, well, let's just do socks and shoes, okay? Put my socks on and then my shoes. All right. Now, if I'm going to undo that, can I take my socks off first? Okay, only if you have slip-ons on so that they come off with them, right? Okay. But to undo that, you have to go shoes and then socks. So you have to think of it that way, that if I subtracted and then multiplied, well, then to go backwards, I have to divide and then add. Okay, I can't add and then divide. I have to divide and add. Okay, so here we have f of x equals negative 1/2 x minus 5. And I'm actually going to take you through this 2 different ways, and if you like the one more than the other, then use it. Okay, Jocelyn? All right. So, okay, let's do what we just did first. Okay. All right, so if I'm going to do stuff to x here, okay? In other words, if I put a number in there for x, what's going to happen? What order are we going to do it in? What's the first thing I'm going to do? Okay? Order of operations says, do we multiply by negative 1/2 first, or do I subtract 5 first? Okay? We multiply before we add and subtract, right? So the first thing I would do to x is I'm going to multiply by negative 1/2. All right? And then we would do what? Okay. And then we'll do the adding or subtracting. So subtract 5 then. Okay. So to find the inverse of that then would be, what will I do first? Okay. All right. We go backwards, right? So if I undo that subtracting 5, I'm going to add 5. And then I'm going to do what? Okay, divide by negative 1/2. Oops, negative 1/2, which is the same as what? Well, it is the same as 0.5. Okay, but if I'm dividing by a fraction, that's the same as doing what? Multiplying by the reciprocal. So this dividing by negative 1/2, I could also say multiply by negative 2. Okay, the reciprocal. So let's see what it would look like. F inverse of x equals, so I'm starting out with x, and I'm going to do what to it? Add 5. All right. And then I'm going to take that whole thing and multiply it by negative 2. Okay. So this is equal to negative 2x minus 10. No. All right, so let's look at it a little different then. Let's think of this as y equals negative 1/2 x minus 5. So here's the other way. Here's what's actually happening, okay? What's actually happening is we are going to switch x and y and solve for y, okay? Because we just said inverses are taking all of our x values and our y values and switching them, right? Okay. So instead of this being our y-intercept, it's going to be what? The x-intercept, okay? So we're going to switch x and y. And this is what I'm telling you. You can choose which method you like. If you like this because it actually walks you through the steps, that's fine. Or if you want to think of it this way, which in reality all I'm going to do is the same thing. Oops. Sorry. All right. So I switched x and y, and now I'm going to solve for y. Well, what's the first thing I'm going to do to solve for y? Okay. Add 5. What did we say finding the inverse? The first thing we did? Add 5. And what was our second step for finding the inverse? Okay. Divide by -1/2, which undoes the multiplying by -1/2, or multiply by -2, the reciprocal. And what do we get? -2x minus 10. So we got the same thing. Either way you go about looking at it. Okay? So if you want to think of it as the undoing stuff, and I can go from the start to finish that way, or if you want to switch number 1 and then solve for y. So either one of those two things will get you the right answer. Here, all right? Now, you don't necessarily have to write this down, okay, like I did, but I wrote it down so you could see it. But you think about it, okay, what am I doing to x? Multiplying by -1/2, subtracting 5. Okay, what's the opposite of that? Okay, adding 5, dividing by -1/2. Okay, and if you can get your thought process through that way, you should be successful. Okay, all right, so do number 3. Just do number 3.